Hello everyone, here are the solutions to 9 through 12. I have a separate video posted walking you through how to solve these, so be sure to watch it if you did not get these for your answers. All right, what we're going to move on to today is something called complex fractions. That's where we see fractions within a fraction, so our job is to be able to know how to simplify them so they're no longer complex fractions. All right, so again, to identify what a complex fraction is, and you can tell just by looking at an example, they're fractions whose numerator, I'm just using a capital N for numerator and capital D for denominator, so fractions whose numerator and or denominator contain a fraction, so fractions within a fraction. Our job, we're still going to use the LCD, in order to simplify, is to multiply the numerator and denominator, everything, by the LCD. So again, many uses with this LCD here. So go ahead and copy down number 1. What's nice about this is that they are all numbers, so we always start off with numerical examples and then it builds into expressions. Now yes, there are a couple ways to do this, but using this technique is going to be the most efficient. All right, so if you take a look at the individual denominators within all the little fractions here, we have a 2, we have a 3, and we have a 6. So I want the LCD of those. So 2 and 3 can both go into 6. So that means what I want to do is take both numerator and denominator here and multiply by a 6 or a 6 over 1. Again, the LCD is 6. So I carefully want to distribute up top. 6 times 3 is 18. 6 times 1/2 is 3. See how nice these numbers are now? Fractions go away. Same thing down here. 6 times 1/6, or 1/6 of 6 is 1, minus, and when we multiply here, we can multiply straight across. We're going to get 12 over 3, or we could say 2 times 6 is 12, and then divide by 3, or 3 goes into 6 twice, and then we end up with a 2 times 2. Either way, we're going to get a 4. So now this becomes 21 over negative 3, and we continue to simplify until we get a negative 7. Let's bring in the variables. Go ahead and copy down number 2. All right, so again, we're looking at this 3 and the 6. The LCD of those is 6 again. So I'm going to multiply top and bottom. Notice how I'm putting these in parentheses by 6 over 1. So I'm going to distribute. 6 times x is just 6x. Here, 6 times x over 3, 6x over 3 becomes 2x. Down here, 6 times x is 6x, minus 6x over 6 just becomes x. Now I have a much nicer looking problem here to simplify. So up top, we are going to get an 8x. 6x minus x is a 5x. And now, yes, those x's will divide out, and we're just left with 8/5. Copy down number 3. We no longer have numbers in our denominators. So the LCD here is just going to be a times b. So I need to multiply top and bottom by ab, or really ab over 1 is going to help. So now when I go to multiply, and if it gets a little too complicated by looking at it, we can kind of still keep the fractions in the problem for the first step and then simplify. So as I go to multiply ab times 1 over a, I'm going to first write it like this: ab over a plus, next I'm going to get ab over b, and we'll simplify in the next step. Down here the same, I'm first going to get ab over a minus ab over b. So now these a's cross out, so I'm just left with b. Now over here the b's cross out, so I'm left with a. In our denominator, the a's cross out, so I'm left with b minus, what do you guys think? An a. And that is our final answer. Now we could have gone straight to this, but like I said, I wanted to show this step just in case you needed to see how we were coming up with that final answer. Go ahead and copy down number 4. very careful as you copy this down though. All right, here the LCD. This x cannot go into x plus 1, so I need both of them. My LCD is x times x plus 1. And again, I'm going to do the same thing I did in example 3. I'm going to write all this out. So when I go to multiply the LCD by the first fraction, I'm going to get x times x plus 1 up top, because 1 times this is just this, over x, plus, again, I'm going to get x times x plus 1 up top, over x plus 1. At the bottom, same thing, we'll get x times x plus 1 over x, but minus x times x plus 1 over x plus 1. And then yes, now we can cross out these x's cross out here, x plus 1's cross out here, x is cross out here, x plus 1's cross out there. So now up top we're left with x plus 1 plus x. Down at the bottom we're left with x plus 1 minus x. Up top we're going to get a 2x plus 1. Now in our denominator, these x's are opposites, so they cancel out, and I'm just left with the 1, so I don't have to put this over 1, so our final answer is just 2x plus 1. All right, and just one more example. Go ahead and copy this down. All right, now these n's are just over a 1, so the LCD really is just n plus 1. So I want to multiply top and bottom by n plus 1. So as I go to distribute here, that's first going to give me n times n plus 1, no fraction here, plus, now I am going to just kind of skip ahead to this step. If I multiplied n plus 1 by this fraction, the n plus 1's are gone, and I'm just left with n minus 3. Same thing in our denominator. N times n plus 1 goes first. Minus, though, the n plus 1's will cross out, and then we just have a minus 6. Now, no, I cannot cross out these n plus 1's yet. Why not? Because I'm still adding and subtracting some terms. So I need to distribute. So now I'm going to get n squared plus n up top, plus n minus 3. Same thing down here, n squared plus n minus 6. Still can't cross anything out. Combine these two n's, so we get n squared plus 2n minus 3 over n squared plus n minus 6. Still can't cross anything out. Because imagine if I just gave you this problem, and we've been practicing these for some time now, we'd have to factor first and then cross out. So let's factor the numerator. Go ahead and see what you come up with. There's no GCF on the top or the bottom, so let's just make two sets of parentheses in both parts of the fractions. All right, so factoring the numerator, we'll have an n and an n. We'll have a 3 and a 1. Our signs need to be different. If we had a plus 3 minus 1, we would get a plus 2n. In our denominator, we start off with n times n. Let's do a 2 and a 3. I need to end up with a positive 1n, so how about plus 3 minus 2? So now our n plus 3's can cross out, and we're left with n minus 1 over n minus 2. So these problems look very different, but it's still the same process. We're taking the LCD and we're multiplying the numerator and denominator by it to simplify these complex fractions. So this worksheet has 6 problems. This will also be scanned separately for you guys to view. But please make sure you do all of this. If you print this out, please do this on a separate sheet of paper. And always let me know if you have any questions.